first of all, thanks a lot to EPIC for organizing this nice online meeting. So as you said, I'm Martin and I work at UNM Research. We are a non-profit research organization in Austria, in Weiz. And I'm working there at the Materials Institute, where we have 5 core topics, 5 research groups. And actually 3 of them are contributing to our biosensor related activities. So at our institute, that's a rather interdisciplinary teamwork. So what do we do in the field of biosensors? So we are all asked of what we can offer to others. So I will start with that. First of all, we work on sensor chemistry, so on the molecules, which are the real sensing part in the biosensors. We very much work in the direction of upscaling, so we print, so we apply this sensor chemistry in printing processes. As most of our sensors are optics-based, so the detection is based on optics, we are working on micro-optics. And then for the final upscaling, for the manufacturing, we work on the materials which we need for replication. So there we are also working a lot in the direction of nano-imprint lithography, like it was also presented by EVG before, and we also worked together with EVG in a previous project. So we're then working on a topic which was not mentioned so far, so on large area upscaling on polymer foils. So we can maybe give here an addition to the collection of manufacturing approaches. So, so what I will present is mostly polymer based, and our special topic is the replication on large area polymer foils. So first of all, how is that done? How is polymer foil based manufacturing done? So we are implementing so-called roll-to-roll processes, so which probably all of us know from printing industry, so from print industry, for example, from newspaper printing. So we go from small substrates to, let's say, endless foil substrates. And so like in semiconductor industry, there's always a tendency to increase substrate size in order to bring down the prices per unit and to increase the total throughput. And this approach we are also applying here. So we changed to a much bigger substrate in form of these polymer foils. And then, so our benchmarks are typically that we can get hundreds of chips per minute. So we drastically increase the throughput. And the next step is that we can parallelize the following processes on these big substrates. So we don't need to handle individual chips. And so far this has been demonstrated quite often already in the past, that it's possible to replicate, let's say, the microfluidic structures for biosensors on foil substrates. But then we also went one step ahead. So together with Cynian, we made a microarray spotter, which works on this foil format. So we first imprint microfluidic devices, and then we have a multi-channel, let's say, biomolecule printer. This is this roll-to-roll microarray spotter, which is a rather unique contribution from our side. So we can print multiplexed patterns of biomolecules on these foil devices. And then an important project which was already mentioned, so that's Medfab, which is a pilot line project for advanced photonic medical devices. And with the presented technology, we are also contributing in that platform. And there is also this concept that external customers can request implementation of their technology in the Medfab platform. So far, that's my answer on the question, what do we expect from outside? Then, yeah, I have a final slide. So I think it was already, the topic was mentioned on a lot of presentations before. So the current pandemic virus crisis, where we need a lot of tests, we have already seen that there are biosensors which can help us here. So which do allow us quick tests either for the virus itself or for the immune response. And the contribution which we can make is the upscaling at many pieces. So when we say high throughput manufacturing, we talk about at least 1 million pieces per year and more. So with our platform, where we switch to these hundreds of chips per second, per minute, we are way beyond the classic manufacturing capacities. So that is a valuable input here from our point of view. Then I want to thank our partner network here from Medfab and NextGen Microfluidics and the European Union for funding our research.